If a positive charge of charge q mass m enters into a magnetic field which is acting outwards here, field is outwards. So this is the magnetic field which is acting outwards, that is along z axis. Now it enters into a magnetic field with velocity u and it leaves this with velocity u only. So the velocity, magnitude of velocity throughout this path never changes. So first point what we can write, the velocity with which the charged particle comes out is not equal to the velocity with which the charged particles enters here. Why? Because the direction will change, but the magnitude of these two will be same. So we can write, so velocities are different. But what about the speed? Magnitude of the velocity is called speed. The speeds are equal. Now, third one, here I want to find out the distance traveled by the charged particle within this magnetic field. Here this is given as theta and this will become 90 minus theta, and this radius r is perpendicular to this particle. So as it is perpendicular, this is also theta. Now if it is theta, this angle must be theta. Why? Because these two are radius and radius. So these two sides are equal, these two angles must be equal, and this angle as it is right, this triangle, this is 180 minus 2 theta or pi minus 2 theta. So what is the angle described the charged particle within the magnetic field when it is leaving this one? So this I will take it as phi. So total angle described is called phi. So phi is given by, what is this phi value? Remember students, the total angle separated center will be 360 degrees, that is pi minus 2 theta plus phi is equal to 360 degrees. So this is 2 pi. So now you can write phi as, this is the angle described at center, phi is equal to 2 pi minus pi minus 2 theta. 2 pi minus pi is pi, minus or minus plus 2 theta. So phi is equal to pi plus 2 theta. This is the angle described at the center. If you know this one and if you know the radius, then you can find the distance described, the distance travel, which is given by r theta. So this is r into theta, r, actually I should write r phi here, r phi, which is equal to r into 1 plus 2 theta. This is the distance traveled. So what is the time taken here? The time taken to complete this circular path is given by time spent by the charge within this one is given by distance traveled by speed, that is r into pi plus 2 theta by speed is equal to v. So this is the time spent by this charged particle within this one. If it is a positive charge moving, enters into magnetic field perpendicular to this with velocity u and leaves this one with velocity v. So please remember, velocity's direction is changing, so velocity vector is changing, but the speeds are same. The velocity with which it enters into the magnetic field is equal to the velocity with which it leaves the magnetic field, only the magnitude, but the speeds are same. Third one, angle described at the center is this much. From this you can find the distance traveled, and by using this one you can find the time spent also. Now in this case, I am taking a negative charge here. This is not positive charge, and field is entering into this one, and the charge is entering perpendicular to the field only. Here this is the magnetic field, and the charge is entering, it will experience a force like this. Now, if the charge is negative, this is the direction of the positive charge, but here charge is negative, so I have to rotate my finger such that field is in the same direction. This is the direction of the positive charge. It will experience force like this. Due to this, it will experience centripetal force and describe a circular path. Now in this case, what we can write, the velocity with which it enters into the magnetic field is u, the velocity with which is leaving the magnetic field is v. But the direction of the velocity changes, magnitude of velocity never changes. So first point similar to this, v bar is not equal to u bar, as velocity direction of velocity changes. Second point, here the magnitude of velocity is same, so speed is same. So v, magnitude of v is equal magnitude of u. So speeds are equal. Third case, here you can see this is alpha and this is beta, and as the speeds are equal, the angle described this one is also equal. You can write alpha is equal to beta. And the fourth one, what is the radius of the circular path described by this one? So r is always equal to mv by bq. Only the radius, I am not talking the total circumference, only the radius is like this. Now if it is alpha, as it is a perpendicular line, this will become 90 minus alpha. If it is beta, this will become 90 minus beta. So what is this angle? So this theta will be given as, here I am going to write theta will be equal, this is I am going to write theta. Theta is 180 minus 90 minus alpha, 90 minus beta. As alpha is equal to beta, I can write 90 minus alpha, this is also 90 minus beta. So what is this theta? So pi 180 degrees minus sum of these two. 90 minus alpha, 90 minus alpha, 90 plus 90, once again 180 minus 2 alpha. So these two get cancelled. Theta is equal to 2 alpha. So what is this angle? This angle must be equal to 2 alpha. So what is the angle described by the charge at the center? So that I am going to write here. Phi is given as pi plus 2 theta. Here phi is given as 360 degrees minus this theta, that is 2 pi minus theta. So this is the total angle described at this point, and theta is given as 2 alpha. Next, the time spent by the charged particle inside the magnetic field is given by time is equal to total distance traveled by total speed here. This is the angle. So the total circumference of this one, in this one, is given by r phi, which is equal to r into 2 pi minus theta by v. So this is the time taken by this charged particle to complete this path within this magnetic field. In this case, see this one. Once again, a negative charge is entering into the magnetic field. This is the field, this is the charge, but this is outwards. But here it is experiencing force inwards. Why? Because this is negative charge. So I have to write it like this. So it will experience a force like this. This is the center of the circular path described here. So when it is entering into this one with a velocity u and leaving this with a velocity v, in all cases we can write the first point as magnitude of velocity that is leaving the field is not equal to the magnitude of velocity that is entering the field. So velocities are different. But what about the speeds here? Magnitude of the velocity that is leaving must be equal to magnitude of the velocity that is entering. That means speeds are equal. Now, here, what is the angle described by the charged particle within the magnetic field? So this I am denoting with phi in all the cases. This is phi, this is phi, and this is phi. Now suppose if the angle is given here, let us say the angle made by this one with this one is alpha. If it is alpha, now you can write this is perpendicular 90 minus alpha, it is perpendicular alpha, this is 90 minus alpha. So this is also alpha, and this will also become alpha. Now third case, what I am going to write here, the angle at which it enters here is equal to the angle at which it leaves. So directly we can write alpha is equal to beta. And fourth one, the radius of this one, which is given by radius circular path described, is given by mv by bq. This is fourth one. Now I want to find out the angle described at the center by the charged particle. So I need this angle. So it is clear that if it is alpha, it is perpendicular to this one. This is 90 minus alpha. This is also 90 minus alpha. Sum of these three must be 180. So 90 plus 90 already 180. So this is 180 minus 2 alpha plus 5 must be equal to 180. 180, 180 get cancelled. Phi is equal to 2 alpha. So phi is equal to 2 alpha. Now after finding this one, I can find this distance travelled here. Distance travelled, which is going to be r alpha. R alpha, that is r into alpha is equal to this phi is equal to 2 alpha. So what is this 2 alpha already given here, so we can substitute this one. Just what is the time spent by this charged particle? Time spent is given by distance traveled by speed, that is 2r alpha by v. Or sometimes we can say that if you know this angle phi, we can write for 2 pi radians for complete circle, it is taking capital T seconds. For 5 radians, it will take some time, the time we are finding here. So let us say this time is t. Now if you divide these two, you will get t is equal to t phi by 2 pi. This is also equal to capital T phi by 2 pi. Case already we solved this problem. The first case is v not equal to u. Second case, magnitude of v is equal to magnitude of u. Here it is entering perpendicular to this one, it is not making angle but it is leaving here. So third case we can write r is equal to mv by bq, and the angle described by this one at the center. So this I am going to denote with phi. So if you know this phi value, this will become 90 minus phi. This is phi, this is 90 minus phi. So theta is equal to phi. So phi is nothing but the angle theta there. Then fifth one is distance traveled. Distance traveled is given by r into phi. R is equal to mv by bq into phi. So this phi is nothing but theta, which is also equal to r theta here. Now after that time spent is given by r phi by speed v. But here sometimes they may ask to find out this value, which is given by sideways movement, sideways deflection, which is given by, so if it is r, this is r cos phi, this will become r minus r cos phi, which is given by r into 1 minus cos phi. When a charge q enters into a magnetic field, if theta is 0 degrees, charge moves in a straight line path. If theta is 90 degrees, that we discussed till now, it moves in a circular path. Here not only 0, even for 180 degrees also, either parallel or anti-parallel, it moves in a circular path. 90 or 270 also, it moves in a circular path. If theta is not equal to 0, not equal to 90, not equal to 180 degrees, not equal to 270 degrees, and multiples of 90, then the charged particle moves in a helical path. So now we will discuss this point. If you take a magnetic field which is acting like this, let us say this is the magnetic field which is acting along x-axis, so B naught I cap. So in this, a charged particle enters into this magnetic field at an angle theta with the field. So this is the angle described this one. So let us say it is entering into the magnetic field like this. Now the velocity with which the charged particle enters into this one is v naught, and as it is a theta, the horizontal component of velocity v naught cos theta, the initial vertical of velocity is equal to v naught sin theta. Due to these two different velocities in two different perpendicular directions, the particle will try to move along x-axis as well as along y-axis. Due to this, the particle will have a mixed motion, that is motion along x-axis, motion along y-axis. But always the velocity component which is perpendicular to magnetic field will give a centripetal force and will provide the circular path for this charged particle. So due to this, v naught sin theta is responsible for circular motion, because v naught is perpendicular to magnetic field here, and v naught cos theta will provide straight line motion as it is parallel to magnetic field. See here, when theta is 0 or this component, velocity component which is parallel, anti-parallel to magnetic field will provide straight line motion. So this charged particle will have two different motions. One is straight line motion, one is circular motion. Due to this, the charged particle will describe a helical path here. Now, so this helical path is a resultant of two different motions. One is a straight line motion, the other one is a circular motion. It is having this helical path. What is the time taken to complete one circular path? Circular path. The time taken here is, first of all, we will write which component will provide the centripetal force for this one, mv sin theta. So what is the force experienced charged particle due to this velocity? So the magnetic force is given by F magnetic is given by BQV sin theta. This is BQ V naught sin theta. This is the force experienced by the magnet. Why? Because as this velocity is parallel to the field, this velocity will not provide any force. Only this velocity will provide the force here. So this is BQV sin theta, which is equal to mv square by r. That is m into v square is also v naught sin theta whole square by radius r. This and this get cancels. The radius of the circular path is given by mv sin theta by bq. So this is the radius of the circular path. Whereas in case of that perpendicular, when the charge enters a perpendicular, this theta will become 90, this will become sin 91. So we got r is equal to mv by bq. As theta is not equal to 90, so this will become mv sin theta by bq. mv sin theta by bq, this is the radius of the path. Now, if you know the radius, we can find out the time period of this one. Time period to complete one revolution in this helical path is given by 2 pi r by v naught sin theta. Because this is related to v naught sin theta, so you can write 2 pi by v naught sin theta. R is equal to mv naught sin theta by bq. You can cancel v naught sin theta, and the time period will be equal to 2 pi m by bq. So this is similar to the previous case where the charged particle is moving in a circular path. The radius will be different from this one, but the time period will be same. That means the time taken to complete one circular path will be equal to 2 pi m by bq. Now, after this, what is the distance traveled by the charged particle in one time period? So let us say it is completed one time period, one circular path here. So to complete one circular path, it is traveling some horizontal distance. The horizontal distance traveled by a charged particle one time period is called pitch. So pitch is defined as horizontal distance traveled in one time period. So P is given by, what is the horizontal distance? As it is not experiencing any force in this direction, because B and V naught cos theta is parallel. When both are parallel, anti-parallel, it will not experience any force because F is equal to BQV sin theta, theta will be 0. So the force will be 0. So pitch is given by, when force experienced along x-axis is 0, the acceleration along x-axis is also 0. So the horizontal distance is equal to Vt, that is V naught cos theta into time taken to complete one circular path is given by time period, this is t. So pitch is given by V naught cos theta into 2 pi m by bq. So this is the pitch of the helical path